Hey guys, I'm back with another video. Getting helped with the puppies because I think we're going outside right now, which we are here in a minute. But into the meat and potatoes of what this is about. So we are building a small cabin out in the woods. I had the idea originally, and then when my mom came home, she saw us already grading the ground and everything, getting it ready, and so we kind of took off from there and started working on it. So in front of us right now is the bare bones of the power out there. So the idea is this cabin's gonna be fully off-grid. Wood burning stove in there, a small countertop, because the wood burning stove has two burners, I guess you could say, on it, where you can actually put pots on it. It's like 36 inches long, so it's like from the edge over there, it's probably almost the entire length of this bench, because this bench is 4 feet. So fully off grid. So wood burning stove for heat. We're gonna put in a window. I'll show you what we're doing for siding and roofing. The roof is actually gonna be clear, so it'd be even brighter in there. So right now this is a panel. My mom did a panel change out, and I always get the spare panels. I have a lot of them now, but this is a perfect one because it's only 6 breaker slots. Yes, I know. We're gonna go out here in a minute. Dogs love to cry. So let me open this up. So plenty of extra spare fuses, bus bar right there. So you can see it's only 6 breaker slots. I'm gonna remove all of these. I'm gonna have for power out there, so we'll just run in a quarter right here because it's gonna be running I'm gonna have 2 inverters. One is a 2000 watt. I'm using Bestech inverters off of Amazon. They're cheap, and I found they are the most reliable inverters I had. I have a 1000 watt Bestech inverter, and it literally has the entire front end cave in where the plugs are because I dropped it so many times, and it runs just fine. It doesn't complain, there's no issues with it, and so then the power will probably come in top side, maybe bottom, or maybe over here on the side. I'll bring it in, and then that knockout's way too big, so I'll just bring it in up here to that knockout, and then we'll just run in neutral. We'll just tie the hots together, or I may just use one half of the bus bar, because if you don't know how a panel is, you have 2 different bus bars because you have A and B of your split phase, so 120 between that to neutral, and B is 120 between that to neutral, but between the two is 240 volts because the transformer is a split core, or it's a center tap transformer. If you guys want me to make a whole video on that, I can get into it. It's not that horribly complex. Getting into why things are grounded and all that is a whole nother story, because I'm going to have to do more research on that if I want to actually, depending on how I want to build this place. But so then you can see 2 bus bars, each one of them. So I may just use this bottom one because it has more terminals on it. So I may use that. I don't quite know what I want to do yet, but oh well. It's going to be interesting, so I'm just really excited for this. It's going to be fun. So then you have your main or spare main neutral over here. I got this one out of another panel we redid, so I can use this. I have a couple of these now because if you don't know, Federal Pacific panels are illegal. I'm pretty sure these are the bus bars out of them, but bus bars are just metal. You can't make them illegal. I don't know how you could. So I get these all the time. I'm going to use this for solar combining. So that's the panel side. Speaking of solar and everything, and here is a 500 watt pure sine wave Bestech inverter. So I want to have one outlet for a pure sine wave for anything important I want to plug in. So that's why I got this. It's an amazing inverter. I don't know if you can actually read that, but it's ETO listed. Intertech. Intertech. But the label itself says ETO listed. Pure sine wave inverter, 11 to 15 volts. Output is 120 volts, 60 hertz, 500 watts. The output voltage itself, it sits at 114.5, 114.4 to 114.6 is the range. So that's from my testing, and it runs phenomenally. And then you have 2 USB ports on it for 2 amps each port, which is amazing. So then that's the inverter side of things, at least one inverter. The other 2000 watt inverter is actually down in my shop right now. Hi, Callie. You're interested? So then in here, for $298 or something, or it was like $278, it was for $278, you can get a 200 watt solar system with 20 foot, it's a full kit, So you have 20 foot of number 10 cables. This is an MPPT, maximum power point tracking, solar charge controller. So in here, it has a nice display. I've already turned it on and everything, and it's actually got plenty of readouts. 2 mounting bracket kits for each panel. I'll do this one-handed. And then your actual charge controller itself. And the charge controller itself is built great. The terminal lugs on there are rated for, I think you can probably get number 8 in there. Pretty large wire. It's got plenty of actual, it doesn't come with a temperature sensor, but you can get one for it. Or you can just buy the right connector and put it on there. Some of their other models actually have USB file sharing, and so you can actually download log files, I'm pretty sure, from this, and it also has Bluetooth support on some of it. This is a cheaper model, so it doesn't have any of that, but it does have over voltage, over current, everything. So there's display lights on there. Trying to do this all one-handed. So here's the actual charge controller. Fits in the palm of my hand at least, or takes up the entire length of my hand, which my hand is pretty large. So you have your solar here on the left, battery on the right, 3 indicators. One is your solar panel, one is your actual battery charge state, and the one on the right that says set is your actual battery set type. So if you look on the side, let me see if I can angle it. There you go. So all the different colors mean something. So you have sealed lead acid, gel lead acid, flooded lead acid, 12 volt and 24 volt lithium ion. So this inverter, this charge controller supports up to 24 volt systems. I'm running at a 12 volt. And then you have white, which you can also use or customize it. And then the solar array indicator, it actually shows you what all of them mean. So if the light's completely off, it means it's not doing anything. Quick flashing is it's equalizing the battery. Double flashing is current limiting. If it's steady on, it's MPPT charging. Slow flashing is boost charging, and single flashing is float charging. So, and then your other battery indicator is green for full charge, yellow for battery normal, red is steady on, or red or steady on is battery low voltage, and red quick flashing is battery over voltage or over temperature. So then on the front side, your terminals, pretty good size. I'd say they're 1/4 inch thick or 1/4 inch wide, maybe a little less than that. And then you have your temperature sensor right here, and then a comm, and then you can set it on here, or you can set it on the display. So that's that side of things. Pretty awesome. The panels haven't come yet. They'll be here in a couple of days. It's taking a little bit of time. But then what we just got, and I'll show you what the cabin's going to be made out of. So here is the actual roofing and the siding. The place just down the road is redoing all their greenhouses, so we just got a lot of these greenhouse siding panels. They are all clear, but these are paintable as far as I'm aware, so we'll sand them down a little bit. It'll be a lot of work, but oh well. And then we're going to paint them, clean them, sand them, paint them, at least for the side walls. And then the roof is actually going to be completely clear, which is going to be cool because you can just lay in there or during the day have plenty of sunlight. In the winter, it lets plenty of light in. And then the solar will actually be out in the field because it's only about a 20-30 foot run. So that's going to take care of all of our lighting, or at least for our light coming in. We have like a 4 foot wide by 10 inch tall or 1 foot tall window that we're going to put in there. So then I'm just trying to go through this fast because there's quite a bit of stuff to talk about. So then that's everything we're going to be putting in there. So, well, that's at least for the roofing and everything. And then so we've covered power, covered roofing. So let me go ahead and head down to the cabin, and I'll show you guys what it's going to look like. But first I'll stop down at my shop and show you the 2,000 watt inverter. So we'll be right. Alright guys, we're down in the shop. This is the inverter I was talking about. Modified sine wave, 2,000 watt power inverter. Pretty big. Fusing on the side. A lot of these smaller inverters, I say smaller because it's only 2,000 watts. Anything over that's external fusing, they actually put fuses on there. And then you have your terminal posts on the side. I'm missing a couple nuts, which is fine because I'm actually going to put actual metal nuts on there just so I can crank it down with the wrench a little better. On the front side, you have your on-off switch and 3 plugs. No USB ports on this one, and a charging or a actual on state or indicator, which indicates if there's a short, battery low voltage, or if it's just on and running normal. So that's the inverter we're putting out there. I got this guy probably about 6 months ago, and I'm putting it to good use. My 1,000-watt inverter is in my solar generator right there. Don't know what all that crap is on top. I think it's maybe the battery acid's evaporating, and or the water's evaporating, taking some of the sulfuric acid out with it, and I don't know. It's only on top of the battery boxes, but I don't see it on top of the batteries, so oh well. But that's the inverter I'm doing. I was going to put it in here, but this is probably never going to get completed knowing me, so that's the inverter we're doing. I'm doing at least because I'm going to take care of running all the power and stuff. So let's go and head down to the cabin. All right, we're back here at the cabin. It's down in the woods about, I don't know, 30 feet in. And then over there about 30 feet is a field. So I'm debating on solar panels out there in that field or solar panels in that field. Most likely that one over there, just because it's less visible to us, at least. My neighbors, oh well. It's going to be down in the corner, so they don't really notice it. So the structure, 3 telephone poles here, 3 telephone poles here, 1 at that corner, and 1 right here. And these telephone poles were free thanks to Evergy, because we got good buddies over there. One of our buddies forgot to ask one of their guys how much they wanted or what it required to get one, so he just said we can come pick them up. And so we put all of these, except for this one, in by hand. Just me and a couple buddies, a couple friends of my brother's. My brother, I guess you could say plural. We just grabbed them and slid them in there. Each one's got about half a bag of Quikrete in there, and then dirt on top, on all of them. So I mean, they're solid. I can't even move them. So I'm gonna go grab the impact and then take all these scabbing boards off that we just hold them in place. Then we have a 16-footer on the back. And so that one's the biggest one and the heaviest. This one's not even Quikrete. I mean, she got some wobble to her, so that may be a slight problem. I'm not that concerned about it, because all the rest will take care of it, and this will take care of main load bearing, at least. So you can tell they were just recently pulled out a while ago, but never actually stripped to the grounds. So there's plenty of ground wire sticking out of them. But this one weighs probably more than 500 pounds, because we cannot move it by hand. I mean, my deadlift max is over 400. And when squatting down and just trying to deadlift the thing up, I couldn't get the one end off the ground. So it's got to weigh a lot. And so we had it right there. So we hit it with the bucket of the tractor, slid it down the ground right here. Once we got it right there, we attached a chain to it, got about halfway up. That was the most the tractor could go up. And so what we had to do was 3 of us on the underside pushing as hard as we could, slid it upwards, and because it's so big, these are 12-inch augered holes. It actually didn't slide down in there. We actually had to sit there and shake it, and it finally just shaved it all the way down and went in the ground. So it was a bear, but it was worth it, because now we have a full cabin made out of telephone poles, extremely strong. This thing's not going to go anywhere. So that was pretty good. I'm glad with how this thing turned out. So then the backside over here, so this is going to be the main cabin. It's going to be 10 by 14 for the main cabin. But then the outside over here between that one and these two, it was going to be a small outdoor lean-to. The entire roof's going to be at an angle. I think we're going with a 10-degree slope on it. So we're going to shave. These are 12 feet tall, minus 3 feet, 'cause it's already in the ground. We're going to shave 6 inches off the top of all these is the game plan. And then it's going to come down, and then we'll shave as much as we need off of those. And then this is all going to be open, so for wood storage for the wood-burning stove. And so the idea is, my idea is having wood-burning stove like right over here somewhere. A small countertop right here with some pots and pans so you can cook and stuff, like if you ever bring food out here, if you want to stay out here for a little while. Over here in this corner, I want to do solar and stuff. So put my charge controller. I have 4 35 amp hour sealed lead acid batteries that I'm going to put out there. I bought them for an e-bike project, but it kind of didn't work as well as I thought, because using an alternator motor really isn't that great unless you got the time to modify it and put a Hall effect sensor in there. So I'm just going to use the batteries in there. And so when we're building it and framing it in, I'll plan for a shelf right here, and I'll put the batteries in the corner, so the shelf will take all the weight of the batteries. On the other end will be the panel and other stuff, and it'll be a little small cabinet, so it's not wide open. And then probably going to do like a military cot, like right here, and then a small like cabinet, or over here a small cabinet. It'll have two 12-volt lights in there. All the lighting in this is going to be 12 volts. Outside, like I may do an outdoor light, 12 volts as well. Just because there's no point in stepping it up when I already have 12 volts, and it's just too inefficient to do that, in my personal opinion. So there's a way to actually prove that it's inefficient if you can actually buy 12-volt light bulbs that are 9 watts a piece, instead of stepping it up to 120 volts, putting it into a 9-watt light bulb. Once you get through all the efficiency issues with the modified sine wave, you lose power, and so there's no point in doing that. So that's the whole power thing. I actually have cell tower rated number 10 2 conductors, so it's black and red because cell towers run on negative 48 volts DC. So that's actually one of the batteries I have. I have a massive 180 amp hour, but I calculate it to be somewhere around 200 plus amp hours, because it's 180 amp hours at an 8-hour rating. So at a 1 hour rating, or not at a 1 hour rating, at a 1 amp hour rating, so drawing 1 amp, the amount of time it takes, it came out to around 200 hours it would have taken to drain it dry. So I just only let it go for like 10 hours straight, and then I just did math from there because I didn't want to let it go for, a week straight. So then that's my bigger battery. So once we get a shop, I'll put that out there. And those batteries were used in cell towers for backup. Got that from our friend, as well as that cable. So that cable will just be hand trenched, because this ground is so soft. I'll dig it down like a foot in the ground, trench it all the way out there. You can see the gap in the field right there for the trail entrance. Trench it all the way over there. May have some issues with this water runoff, so I may bring it over this way and then go that way, but I'll decide whenever it gets there, or I may just put it up there. Whatever one is easier and has less chance of damaging the cable. The cable itself can take a lot. It's got double metal sheathing in there, so that's gonna be fine. So 200 watts in solar, 12-volt system at a capacity total of 140 amp hours, 35 times 4. Pretty sure that's 140. I just did that math off the top of my head. I'm not very awake right now. That'll take care of our bulk for capacity. So tomorrow, if my mom's not working, we're going to go and start buying wood, and we're going to go and start framing all of this in. And it's going to be a pretty solid cabin. And we have a leftover pole right there. Is the top end. The end of it's rotten out, but the rest of it. So what we're probably going to do is dig some holes in the ground, a couple inches, like 6 or something, and then use that as floor support, because we already have power line poles. Because if you don't know, power line poles are creosote treated to be weather resistant. But I'll probably stop my ramblings. I think this video is going to be upwards of 20 minutes long at this point. Make it not take forever to upload because I don't have very fast internet. I'll go ahead and wrap this up now. So this is going to be the cabin project part 1. Part 2 I'll film tomorrow of us actually getting it in place. So yeah, this is going to be the cabin project, and door will be over here. Window will probably be on that back side. Clear roof so you can watch the sunset, or you can watch the stars at night, or during the day it lets plenty of light in. But it'll be cool. I'm excited. But anyways, thank you guys for watching. Stay tuned for the next part of this, and I'll see you guys.